Parallel lines. Non-intersecting coplanar lines are parallel lines. Transversal and intercept. A line which intersects two or more given coplanar lines in distinct points is called a transversal of the given lines. In the figure, L and M are two lines and a transversal N intersects them in P and Q. Line N determines 8 angles, 4 with vertex P and the remaining 4 with vertex Q. The following 4 pairs of angles are called the corresponding angles: angle A and angle P, angle D and angle S, angle B and angle Q, angle C and angle R. The following 2 pairs of angles are called the alternate interior angles: angle C and angle P, angle B and angle S. The following 2 pairs of angles are called the interior angles: angle C and angle S, angle B and angle P. Properties of corresponding alternate interior angles. When one pair of corresponding angles is congruent, then all the pairs of corresponding angles are congruent. When one pair of alternate angle is congruent, then all the pairs of alternate angles are also congruent. When one pair of interior angle is supplementary, then the other pair is also supplementary. Alternate angles test. Theorem 3. If a pair of alternate angles formed by a transversal of 2 coplanar lines is congruent, then the lines are parallel. Given, transversal EF intersects 2 coplanar lines L and line M in points P and Q respectively, and angle APQ is congruent to angle PQD. To prove, line L is parallel to line M. Proof. Suppose line L is not parallel to line M. It means the coplanar lines AB and CD are not parallel. Then they intersect in point R. Now points P, Q and R are non-collinear, so we get triangle PQR. Angle APQ plus angle RPQ is equal to 180 degrees as they are angles in a linear pair. Angle RPQ plus angle PQR plus angle PRQ is equal to 180 degrees as the sum of the angles of a triangle are 180 degrees. Angle APQ plus angle RPQ is equal to angle RPQ plus angle PQR plus angle PRQ. We get this from point 1 and 2. Angle APQ is equal to angle PQR plus angle PRQ. Angle APQ is greater than angle PQR, that is, angle APQ is greater than angle PQD. It contradicts the given angle APQ is congruent to angle PQD. So, our assumption is wrong. Therefore, line L is parallel to line M. Corresponding angles test. Theorem 4. If a pair of corresponding angles formed by a transversal of 2 coplanar lines is congruent, then the lines are parallel. Given, line EF is a transversal of 2 coplanar lines and lines L and M, and angle EPB is congruent to angle PQD. To prove, line L is parallel to line M. Proof. Angle EPB is equal to angle PQD, that is given. But angle EPB is equal to angle APQ, that is because they are vertically opposite angles. Therefore, Angle APQ is equal to angle PQD. We get this from point 1 and 2. Therefore, line L is parallel to line M. Interior angles test. Theorem 5. If a pair of interior angles formed by a transversal of two coplanar lines is supplementary, then the lines are parallel. Given, line EF is a transversal of two coplanar lines L and M, and angle APQ plus angle PQC is equal to 180 degrees. To prove, line L is parallel to line M. Proof. Angle APQ plus angle PQC is 180 degrees. That is given. Angle PQC plus angle PQD is 180 degrees. Angles in a linear pair. Therefore, angle APQ plus angle PQC is equal to angle PQC plus angle PQD. We get this from point 1 and 2. Therefore, angle APQ is equal to angle PQD. Therefore, line L is parallel to line M. Converse of alternate angles test. Theorem 6. If the two lines are parallel, then alternate angles formed by a transversal are congruent. Given, line L is parallel to line M. Transversal EF intersects them in point P and Q respectively. To prove, angle APQ is congruent to angle PQD. Proof. Suppose angle APQ is not congruent to angle PQD. Then, according to alternate angles test, draw a line N passing through point P such that angle MPQ is congruent to angle PQD. Line N is parallel to line M, which is alternate angles test, but line L is parallel to line M, which is given, which means that there are two parallel lines parallel to line M passing through the same point P, which is outside the line M. This is contradictory to the uniqueness of the parallel lines. Therefore, our assumption is wrong, and hence angle APQ is congruent to angle PQD. Converse of corresponding angles test. Theorem 7. If the two lines are parallel, then the corresponding angles formed by a transversal are congruent. Given, line L is parallel to line M and line EF is the transversal. To prove, angle EPB is equal to angle PQD. Proof, line L is parallel to line M. That is given. Angle APQ is equal to angle PQD, that is alternate angles, but angle APQ is equal to angle EPB. They are vertically opposite angles. Angle EPB is equal to angle PQD. We get this from point 1 and 2. Converse of interior angles test. Theorem 8. If two lines are parallel, then the interior angles formed by a transversal are supplementary. Given, line L is parallel to line M and line EF is the transversal. To prove, angle BPQ plus angle PQD is equal to 180 degrees. Proof, line L is parallel to line M, that is given. Angle APQ is equal to angle PQD, that is alternate angles, but angle BPQ plus angle APQ is equal to 180 degrees. These are angles in a linear pair. Therefore, angle BPQ plus angle PQD is equal to 180 degrees. We get this from point 1 and 2. Corollary 1. If two lines are parallel to the same line, then they are parallel to each other. Given line L, line M and line N are coplanar and line L is parallel to line N. To prove line M is parallel to line N. Construction. Draw a transversal Q intersecting lines L, M and N in the points P, Q and R respectively. Proof. Line L is parallel to line M and Q is the transversal that is given. Angle GPB is congruent to angle PQD, that is corresponding angles. Similarly, line L is parallel to line N and Q is a transversal. Angle GPB is congruent to angle QRF, that is corresponding angles. Angle PQD is congruent to angle QRF. We get this from point 1 and 2. Therefore, line M is parallel to line N. Corollary 2. If a line coplanar with two parallel lines is perpendicular to one of them, it is also perpendicular to the other. Given line L is parallel to line M, line Q intersects them at points P and Q respectively, and line Q is perpendicular to line L. To prove, line Q is perpendicular to line M. Proof. Angle EPB is congruent to angle PQD, that is corresponding angles, but angle EPB is equal to 90 degrees, that is given. Angle PQD is equal to 90 degrees. We get this from 1 and 2. Therefore, line Q is perpendicular to line M. Corollary 3. If a line is perpendicular to two coplanar lines, then those two lines are parallel to each other. Given line Q is perpendicular to line L and line Q is perpendicular to line M. To prove, line L is parallel to line M. Proof. Line Q is perpendicular to line L. Given, therefore, angle EPB is equal to 90 degrees. We get this from point 1. Line Q is perpendicular to line M, which is given. Therefore, angle EQD is equal to 90 degrees. We get this from point 3. Therefore, angle EPB is equal to angle EQD. We get this from point 2 and 4. Therefore, line L is parallel to line M. Thank you for watching.